Hello friends, Jai Parshuram. Today we are going to see about DevOps. What are the DevOps practices? And we'll also touch base upon Docker, Kubernetes. I won't go through the entire tutorials, but in DevOps itself, I've included some part of it. So this is for network engineers. This is a must-have session for network engineers. Okay. DevOps is a combination of development and operations, focusing to provide quick and continuous delivery of high quality. DevOps consists of dev side and operation side. Dev side consists of plan, code, build, test, and ops side consists of release, deploy, operate, and monitor. Now, a common question that many people have is, what is the difference between release and deploy? Release means it's a management decision that a certain feature is going to be released to the customer, and then deploy means actually deploying it in the production environment. So both these things always go hand in hand. There was no reason, to be honest, to separate them, but if you're asked what is the difference, then this is the difference. Operate means operate the production environment, and monitor means keep monitoring it, means whether our containers are working fine, pods are working fine, application is working fine or not, getting logs, and also getting metrics from Prometheus and other such software which keep on monitoring your application. Means they keep monitoring your application that has any user faced 500 HTTP error or 404 that is does not exist, or that kind of things. So that kind of data, those metrics to be collected, that is done in the monitor phase. A memory trick to learn all this is please, can, Bob, test, or something of that sort. A really dumb operation monthly, something of that sort. You make something up, but basically you should just remember these four things and these four things. It's very easy to remember. Now, what are the tools used in all these stages? So during the planning we use Jira. During code phase we use IDEs, that is integrated development environments. We use Git providers. Best coding practices are that you should always have a microservice architecture, API keys, tokens, and all. They should be kept very securely. Mostly people keep them in Jenkins credentials, or if you are using AWS, then AWS Secrets Manager, or using Vault. Vault is a very old thing. No one does it now. Either if whatever cloud provider you're doing, that provider only keeps a lot of credentials or tokens, or you should use, if you're not using any cloud provider, then you must be using Jenkins, so use Jenkins credentials. Then use feature toggles. So this is very important because let us say your application has 5 teams working on them, and each team has 3 developers. So total 15 people working on the application at the same time. Now let us say that one team is working on global user settings page, and it has a feature that it has a user setting that, do I want a dark theme or a light theme or whatever, colorful theme. So that will be coming from global user settings when that page is completed. So maybe that page gets completed after 2 sprints. So till then, let us say I am only my team is only working on a small page, but that page has this theme wise thing. So I need to check how this page looks in various themes. So how will I go about testing my functionality, and should I take up that story later on after these 2 sprints get completed and that global settings happen? No, it's not needed. You can work in an independent fashion. So what you can do is you can put a feature toggle that, let us assume that the theme is light, and then you code, or whatever is the theme, as per that my page will get updated. Now that value at the moment is not coming, and that's why you will toggle this off. So at the moment the theme is always hard coded to, let us say, light theme. Okay, you have hard coded it. So that is your feature toggle. So after 2 iterations, when that page is there, then you should have one more story to remove that feature toggle. Okay, and that story will be really simple, and most of it is already tested. See, there are 2 types of testing. One is environment ready ship, and another is your feature readyship. So environment readiness is already tested. Right now, only your feature, okay, once you remove the toggle, you have already tested it internally, but still have a proper testing after removing the toggle, and that feature can go away. So that is called as a feature toggle. It's a very good coding practice that you should have. In safe, and another thing is branching strategy. So usually in a safe environment, usually one art works on a few products, let us say. So let us say that that art is working on a few products, let us say 3 products, and those 3 products have three repositories each. So total there are 9 repos that this art is working on, and let us say that every team has to work on those 9 repos, or most of them. So let us assume that every repo is being touched by let us say 15 team members, 15 developers, 3 developers per team, 5 teams. Okay, now per repo there should be only one master branch. There should not be team wise branching, otherwise it becomes really difficult. Just have one master branch, then have one develop branch, or if you want you have it, otherwise many people don't even have that. Only one master branch, and give all the releases from that master branch only. Some people cut out a release branch when they have to give a release. You can either do that, or you can just tag a certain commit and give the release from there, but it's a better practice to cut out a release branch. Now how will every developer work? So every developer will be working on either one story or a bug, right? So they will create a feature level branch, which will be a story branch or a bug branch. Okay, and they will cut it out from the master branch only. Okay, so master branch now becomes the single source of truth for that particular repo. Okay, so this is how all the teams work. So this kind of a branching strategy should be done, and team wise branches should be avoided. Then build. In the build stage, we use package managers like these. So dependency is managed by all these package managers. Dependency hell is avoided now, and for building we use pipelines also. So they automatically run the unit test also. They see whether the build is failing. No, it is not failing. Then they do unit test cases. If are they failing? No, then they go about doing load testing, everything, and when everything passes, then and only then that code is actually deployed on various environments. Now you can have this setting that the same pipeline can deploy it on a dev, test, prod, pre-prod, or whatever environments you have. You can do all these things using Jenkins or any kind of CI/CD pipeline provider tool. So either Jenkins is an open source, you'll either use Jenkins, or if you are using any cloud provider like Azure or Google Cloud Platform or AWS, then these cloud providers also give a pipeline kind of a mechanism or CI/CD solution. So you will be using that. Okay. Then in the test phase, you'll be using all these things. You know all these things now. Jasmine and Karma are used in mean stack or MERN stack, means anything concerning JavaScript. Those projects usually use Jasmine and Karma. SAS the tools are those tools which are doing the white box testing of your code before it is compiled or run, and thus the tools are those tools which do the black box testing of your code after it is deployed and while it is running. Now release, deploy and operate. So in all these 3 phases, basically you're using Docker, Docker Compose, Kubernetes, Argo, Istio. So understand these one by one. Docker is introduced because there used to be a problem that developer used to say, okay, this code is working on my machine, but it does not work on anybody else's machine. Now that is because there must be some dependency which is installed only on that developer's machine, and it is not installed on other developer's machine, and that is leading to the crash or whatever. So people thought that let's have a virtual machine, and it should have all the dependencies installed on it, and we will package your software along with every dependency and everything. So that was called as virtual machines. It's a very old thing. So VMware or that kind of things you must be aware of. So that is virtual machine. But then later people thought that why are you putting OS also in that virtual machine? If you want to containerize it, then why don't you just have application layer, skip the OS layer. So now when that was done, that became Docker. So Docker is a containerization tool which does not have the operating system containerized, only the application layer. Now it is a intelligent containerization tool also, because what it does is it has various layers. So it basically remembers a software based on layers. So when you install let us say NPM, so Linux and NPM, it will keep in one layer. It is never going to change. Then you will be copying the package JSON to the application or whatever you call it, workspace folder, and then you will be saying npm install. So there one more layer it forms, that okay, what all NuGet packages got installed. These npm packages got installed. After that, it has your application layer, which has all the files that you have, and when you build that, then whatever that dist folder is there, the artifact, that becomes the third layer. So basically when a container is there in Docker, lower few layers can be taken directly from cache, because you are never going to change Linux, you are never going to change npm version. Means very rarely you will move from one npm version to another, and then maybe even if you change, then there are less chances that you will be changing the npm packages, and then there are more chances that you will probably bring a change in your application layer only. So only the upper layer has to be updated every time whenever deployment happens. Lower layers, if nothing has changed, it just copies it from the cache, and that's why Docker is super fast. Then what is Docker Compose? Docker Compose manages multiple containers of the same application. So what happens is, let us say I have an Amazon kind of a website. Now it has various microservices. So all these microservices have different repos. Per repo I need one image, one Docker image, so one container, okay, because that works in one isolation, okay. So per microservice I have images in Docker, but all of those images have to be deployed at the same time, right? And they should be able to communicate with each other, right? So usually in Docker you set them as a part of the same network so that they can talk to each other. So for orchestrating this, that multiple microservices should have different images, and those images should get deployed at the same time, and they should be able to operate together. That is called as Docker Compose. But a refined version of Docker Compose is Kubernetes. Kubernetes is a different tool. Both of them are open source. Many people use Kubernetes also. So Kubernetes just refines this process furthermore. What Kubernetes does is, it says, see, Docker used to talk about an image, and image was manifested as a container. Now Kubernetes says, okay, no containers. The containers, multiple containers can be put in one pod, okay, and multiple pods can be put in one cluster, and you can have multiple clusters. So it's a big orchestration tool. Now what is the advantage of all this? Because normally when people deploy anything, so there is a deployment strategy and rollback strategy. So deployment strategies can be like blue green or canary deployment, or let us say rollover deployment. So if you are rolling over deployment, means let us say that there are 10 pods in your environment. Out of them 10 pods, all of them are probably serving different geographies of the world. So you don't want to install your application, the new version of your application, immediately on all 10 of them. You want to install it on first one pod, and then check whether it is working fine or not. Are users getting 500 error, or is the deployment passing on, or is it crashing, the application is crashing or what? So you need to check that, and if it is successful, then you want to roll it over to pod 2, then pod 3, then pod 4, and every time you're checking whether it is working or not. So this is called as a rolling deployment. So it's a good deployment strategy. So For doing this, normally people say that let's have different pods, and that is taken care by Kubernetes. Okay, now the problem with Kubernetes is that you cannot have a deployment strategy within the pod. One pod gets deployed, that's it. So at max, how many pods can you have? So normally people have 10 pods at max, right? People don't increase the pod number too much. So if there is something wrong in the new version, then also 10% of your new users are going to suffer the consequences, and that is a problem. So they wanted to divert that traffic at a micro level, and for that Istilo came into existence. So Istilo says that in Istilo you can have a setting that only 1% of the traffic is redirected to the new version, and then keep checking it. Again, checking it means monitoring. So monitoring is done using Prometheus, Grafana, or Elk Stack. So Prometheus is for metrics collection, means what is the time required for a page load, or every service, how much is the return time, or whatever it is. Grafana only visualizes that data, and Elk Stack is for logs management. Okay, detailed logs, every click, everything. If that level logs you want to manage, then it is Elk Stack. And also if you want to send any messages, then there are various messaging tools also. So leave those messaging tools at the moment, but monitoring you got, right? Istilo is used for granular traffic management. Ergo is used for intelligent rollback strategies. Rolling out and roll back strategies, they are more intelligent when Ergo is there. Why? Because Kubernetes only focuses on basic vital signs. Is the pod up or not? Is the container up or not? Is the application working or not? Means has it crashed? Okay, now the thing is, the application might not crash, but it might be returning wrong output, or maybe it must be saying 404 error or 500 error or whatever. Even in that case, it's a bad deployment and you should be rolling it back. But Kubernetes is not intelligent enough to understand that. So Ergo is intelligent. Ergo gets matrices from Prometheus. Prometheus is very good for collecting this kind of detailed matrices. And then it makes its decision whether it has to roll back or not. So Kubernetes is dumb and Ergo is intelligent. And both of them try to make the decision whether I should be rolling back or not. So whether the rollout is successful or not. So both of them are trying to do the same thing. But Kubernetes is dumb as compared to Ergo. Okay. Now CI/CD and CD again. So many people get confused with continuous delivery and continuous deployment. So I'll explain everything. Continuous exploration means your product backlog should keep on exploring. So you should keep on exploring how this application should work. Okay, where it should improve. Take the feedback from the customer and keep on improving your product backlog. That is continuous exploration. Continuous integration means all the feature branches are continuously getting merged onto the master branch. So integrate every new feature into the master branch. So that is continuous integration. Again, you'll be using Jenkins for this. Okay, or any cloud provider will also give you CI/CD pipeline. So that CI will be a part of it. Or rather, Git itself is CI. You can consider only Git as CI. But I am saying pipeline because see, the pull requests have to pass, and in many pull requests they usually say that every PR has to go through that pipeline and the pipeline should pass for it. That's why I'm saying Git and Jenkins are involved in CI. In CD, Jenkins is involved. I'll tell you how. CD means continuous delivery. So here there will always be one manual approval committee which will be saying that, okay, this feature, is it good enough to go to the customer? Is it good enough to go to the end user? So that is continuous delivery. Okay, so deployment has happened. In CI itself, deployment happens if Jenkins is involved. But delivery means it now you can say whether you want to deploy it in the production or not. So usually that Jenkins pipeline only works up to UAT. But for production deployment, usually people go for a manual deployment and they undergo a process called as they say change request is to be created. So that is the way they go for it. So ServiceNow you must have heard about. So ServiceNow, if you are using ServiceNow and if you are manually doing installations in the or deployments in the production environment, then you are at CD state, means continuous delivery state, because manually there is a committee called as change manager is there, and there is a CAG is there. So CAG, he heads the CAG, which is a group of very intelligent people on the domain knowledge which tell whether this feature is good enough or not, and then and only then that deployment on production happens. So that is called as continuous delivery. Continuous deployment, on the other hand, is that everything is automated. So automated unit test cases, automated smoke test cases. Smoke testing means just to check whether every page is opening or not, that is smoke testing. Then all the sanity testing means whatever new features came, are they really working or not, or very crucial functionality, test it very deeply, test these, but very few, but test them very deeply. So that is called as sanity testing. And then regression testing means check whether nothing has broken due to the new changes. So regressively test the entire application. If all these things are automated, that means you have spent a lot of efforts on automating the test cases. If that is the case, and if it is a very mature application, like for example MSDN pages, if it is that mature, it has been there since ages, then usually they have continuous deployment. Or Wikipedia, for example, it must be having continuous deployment. So whenever you make a change and it passes all the test cases, then it is good to go. Wikipedia, of course, it must not be doing it because they have to check manually whether the information is correct or not. But you get the idea, right? MSDN also probably has to check. I don't know, I'm not able to get a proper example, but suppose an application is very, very mature and you have automated every kind of a test case in it. Okay, every scenario is covered in the automated test case. Then and only then you go for continuous deployment. So automatically your code gets deployed directly on the production environment. In my 17 years of career, I have never worked on any single project which has continuous deployment. Everyone is up to continuous delivery level only. No one is up to continuous deployment level. Okay, but you let me know in the comment section if you have worked on any such product. Then infrastructure as a code. What is this? So infrastructure as a code is a practice of managing, means what? You will code how your infrastructure should be. See, previously what used to happen is, if I have to deploy something, if I have a website, then I used to maintain the servers also where it is deployed. Then if I have to scale it up, I have to buy CPUs, I have to buy RAM, I have to buy everything. Then cloud providers came, so infrastructure as a service came. So they said, okay, you can we will give you elastic infrastructure. Depending upon the workload, you can increase or decrease the number of servers, you just let us know. But still it was manually, I had to tell them manually that, see, for Christmas season, I will need 10x the infrastructure, and after that you take it off again. So I had to tell it manually. Emails used to be sent and everything. Now that elastic infrastructure has become automated also. So now I just code that number of CPUs. Is it 4 or is it 40 or is it 400? I can code it. Okay. Now I can increase the infrastructure or decrease it, means I can keep it elastic programmatically. So the entire infrastructure is actually programmed that this much CPU, this much RAM, this much memory, this much ROM. So I can decide all that. So that is called as infrastructure as a code. And Terraform is an excellent example because again it is open source, just like Docker, Kubernetes. Why are they famous? Because it is open source. Terraform is also open source. Then every cloud provider also gives this, like Microsoft has Azure, so Azure Resource Manager is there. They do it. Then Bicep is the more refined version of Azure Resource Manager. So ARM, now they have made Biceps. So Biceps means basically this ARM JSON used to be very messy and complex. Bicep is just a abstraction on top of ARM. So they have given you lesser settings. in the JSON. So your JSON is much more simplified as compared to the ARM JSON. Just like Microsoft, Amazon also has Amazon Web Services, that is AWS Cloud Formation. So they have their own Terraform kind of a thing. ARM is Azure's or Microsoft's Terraform kind of a thing. So everyone is having one Terraform kind of a thing. Okay. Now, Pulumi is the modern approach which allows familiar languages like Python, Go, and TypeScript to be used instead of JSON and YAML and everything. Okay. Ansible is not exactly infrastructure as code. It started as a configuration management tool only, but now it is also having these features or infrastructure as a code. So I have just included it as the last option, and I have also given it very clearly that it started primarily as a configuration management tool only, but now it is also used for IAC. Then messaging. What is messaging? Messaging means, let us say you have multiple microservices within your Amazon kind of an application, and they have to talk to each other. Or let us say you have a login service, log something down, logging service, and it has to log every little thing happening with every other microservice. So there are so many applications which record even a single click or movement of mouse. They record everything. So if that kind of a logging has to be done, or that kind of a, you have to be very observant towards the customer, then in that case you use messaging tools. There are various types of messaging tools. 4 types I have given, like very reliable task managers. So what they do is exactly one notification will be sent per stimuli. So on every stimulus only one signal will be sent. That are RabbitMQ or Apache ActiveMQ. But of course, since they are so meticulous, they cannot send too many signals at the same time. So if you want to record every little mouse activity in every little keyboard stroke, then this is not good for you. Then you should go for data firehouses, that is event streaming kind of messaging tools. So the examples are Kafka and Pulsar. Both of them are from Apache only. Kafka is old, rugged. Everyone uses Kafka only. But now this is the new one. Coming from the same company, and Apache is a fantastic company. See, Apache gives you ActiveMQ also if you want very, a reliable kind of a messaging tool, or if you want very frequent messaging tool, then it gives you Kafka and Pulsar also. So Pulsar, sorry. So Pulsar is actually a star which is very heavy, and it pulses electromagnetic waves, so it gives them out. So pulse, that's why it's called as a pulsar star. So Apache Pulsar, really the name is correct. It is that good. Then hands-off cloud services. So hands-off cloud services means all the cloud providers will also give you some messaging service. So like Amazon gives you simple queue service. Google Cloud Platform also gives you a service. Azure means Microsoft also gives you Azure Service Bus. Then lightweight and fast. So Redis, NATs, these are very lightweight and fast. If you want to use it, you can use it because they run entirely in the memory and all. So you get that. And finally, DevOps metrics. So if you are a DevOps engineer, or if you are a release manager or a change manager, then these are the metrics that you usually have to comply to. Mean time to failure, mean time to recovery, mean time between failures. So I'll tell you all these. See, it depends on your product. Suppose I'll give a very vague example. It's not a IT example, but a very vague example. There are some products which, if they fail, then you throw them away and you replace it with some new product. Like a bulb, you never repair a bulb, you throw it away, buy another bulb. And that is why bulbs usually don't go bad that easily. But then there are some products like your car, your motorcycle, which are so costly that you don't throw away your bike when it breaks down. You repair it. Okay. So if your product is repairable, then these two matrices will come into play. So mean time to recovery and mean time between failures. But If it is a bulb kind of a product which is use and throw, then it will be mean time to failure. So out of 1,000 bulbs, what is the mean time, after how many days or how many hours of use your bulb fails? And that determines whether you're a Wipro company or a Philips company. So it depends. So what is the level of your product? It depends upon mean time to failure. Okay, then lead time. Time to commit to deployment means a time from commit to deployment means you have said that okay, we will get this deployment done, and then how much time does it really take you to deploy that thing? That is the mean time of your release engineer, or maybe your release team. That is the lead time. Deployment frequency. So how often do you deploy the code? This is for engineering teams. So what is the deployment frequency of a certain engineering team? Then change failure rate. So percentage of failed deployments, that is change failure rate. Okay, so I hope you got a brief idea about DevOps tools and maybe about networking in general. How much time did I consume? I consumed 30 minutes. Now very quickly I'll go through Docker, Kubernetes, Terraforms. Okay, it's a lightweight, portable. I have covered everything. Docker Desktop, Docker Hub. Docker Hub is a place where it's a registry where you keep all your images and all. So you can publish your images and all. So the Docker version, Docker pull image, Docker run that image. Run means create a container and run that container from that image. Okay, fine. Then Docker for Amazon kind of a website. So this is how a Docker file is normally. Okay, it's too complicated to be explained, but I'll explain very simple pages. Yeah, this is Docker Compose YAML. Okay, so what they did is they are saying that make sure that SH file it is executable. Okay, they are giving every little step. Okay, leave this. You have it on the website if you want to read. Debugging a microservice. So Docker Compose. Okay, fine. It's too complicated for this video. Docker file. This is a simple Docker file which I can explain. See, you say from this image. So this is the image which is already there on Docker Hub, and it knows about it. So it is Node version 22 on Alpine Linux. Alpine is the lightest Linux that you can go for. Work directory is app. So within your container there will be an app folder which will become your work directory. Then it is saying copy everything from my local machine's artifact to your working directory's artifact. So whenever you say working directory is app, everything happens within app. After this line, whatever I'm writing, it will happen only in app folder, that is a working folder or working directory of your container. Then install serve globally. So npm run. So whenever you say run means it is run before the container is active. Okay, and whenever you say cmd, it means when the container is active, container is working, then within the container, in the running state of the container, this is getting executed. So usually cmd is given as an array of strings, and they'll be used like one command will be formed out of it, like serve s this artifact position l and the port number. Okay, so this is how it will be done. Now sample docker ignore file, it is very much similar to git ignore file. So docker ignore basically ignores these things. So these things will never become part of your container. Okay, then making container from image. So docker build and you give the image name. Then running a container, docker run, and you tell the container number. You can also say which port. So -p means port mapping. This is your host machine's port and this is your container's port. Okay, so host first and container later. Then in the Jenkins file also you can integrate it if you want, like this. There can be one stage, and in that stage you'll be saying docker remove earlier images and then docker run as per this image. Okay, And of course, you'll be having another file in the same place, just like Jenkins file is there at the root position of your folder, of your project. Just like that, there will be a Docker file. Again, D will be capital, F will be small, no space, no underscore, Docker file. And that Docker file will look something like this. Okay. And then in the Jenkins, you'll be having this. Okay. Then what else? Docker architecture. Okay, this no one will ask nowadays, but you should just be aware that Docker CLI is at the top, host operating system is there, and Docker engine has Docker daemon. And so what is a daemon? Daemon means anything that works in the background is called as a daemon. So if you have a service that is working in the background the whole day, all night long, so that is called as a daemon. Okay, I think I have covered everything about Docker. Kubernetes, again, you can go through it. kubectl is just like you said Docker every time for Docker CLI. For Kubernetes CLI, you have Kubernetes controller and you call it at kubectl, and then you give all these commands. Again, its architecture is given here. You can go through it. It's not exactly, it's not required for your interviews, but go through it if you are interested. This you can learn on the job as well, but just be a little aware about it. That's it. Again, Terraforms I'm not going to discuss, but I'll just show you how Terraform is. Okay, let's just go through it. Got the idea? So instead of saying Docker, you say Terraform. Instead of saying Docker, you say kubectl, right? Got the idea? Acha, so this is how it is. Now let us test our knowledge by giving some tests. So these are DevOps practice tests or DevOps practices questions. We have 5 questions. Let us go through it. A CEO aims to enhance the efficiency of a development process to reduce the time needed to implement. How much time did I take? 37 minutes. Okay. A CEO aims to enhance the efficiency and development process to reduce the time needed to implement new features. Which of the following should be included in a report to understand the factors affecting the average development time to release new features? Okay. Time spent tracking issues after release. No, because we need to have time before the release, right? From development to release. So this is not right. Then time taken by budget planning meetings. No, not required. Number of, because see, any kind of meetings and planning and this and that, you never put it in any metric. Okay, these are preparation activities. You leave them aside. Number of development man hours. Yes. Post release. No. Post release we are not checking only, right? It's only up to the release. Time spent to test and bug. Yes. Time taken to design review meetings. By design review meetings. No, because average development time affecting the average development time to release. So only development time, so review meetings and design reviews and this and that not being considered. Time taken for retrospective meetings is not being considered. Let us see. No, so I think this must be there then. Yeah. Design review meetings also, because development, okay, means design finalization is also part of development. That's what they think. ठीक है, चलो कोई बात नहीं. Examining the logs. Recently a non-critical system has been experiencing issues. ठीक है. CTO would like a report so that she can track progress on improving the system's reliability. Okay, ठीक है. The system logs show each system event and the time the event occurred. The logs show when the system starts up and when the error occurs and when the engineer started repairs. Okay. System up, system down, repairs begin, system up, system down, repairs begin, system up. Okay, got the idea. So fill the appropriate information in the final report. What is the mean time between failures? Mean time between failures is this much time. So it is in hours. Yeah, it is in hours, minutes. So it is 60 minutes. 60. Mean time to recovery. 8 minute. Sorry. Mean time between failures. Okay. So this was one failure. This is another failure. So the mean time is this much. 1, 2, 3. 3 घंटा. 3 घंटा यानी मिनट में कितना होगा? 180. And mean time to recovery is 1 hour, means 60 minutes. Sorry. Here it was only 1 and here it was 3 hours. 1 and 3 average is 2 hours only. So 120, I believe. अरे क्या गूगली क्वेश्चन है. CI practices. Select the correct answers about continuous integration. All the commits of the master branch should be squashed after merging another branch. No, not at all. Master branch commits should never be squashed. Commits should be merged with the master branch at least once a day. Even if they don't compile. No, if they don't compile, it should never be merged with the master branch. Long-lived feature branch. See, feature branch should never be long-lived. Should not be merged to the master branch until the feature is fully completed and tested. Yeah, that's true. But long-lived feature branches should not be there only to start with. But if you have them, then yeah, you should test them rigorously before you merging them. It is acceptable to have short-lived bug fix branches that are merged to the master branch every day. Yeah, true. Using test-driven development supports good CI process. Okay, true. This is there. Sure. Then this should not be there. See, long-lived feature branches should not be merged to the master branch until the feature is fully completed and tested. So basically they mean to say that long-lived feature branches itself should not be there. Chalo. Incident responses. The CEO of the company understands that sometimes things go wrong. No system is perfect, but she wants to ensure that the company is improving. The metrics could be used to track the company's incident management. Mean time to failure, yes. Mean time to recovery, yes. Mean time to change, no. Mean time between failures, yes. Mean time to deploy, wait a minute. Things can go wrong and she wants to ensure that the company is improving. No system is perfect. Mean time to deploy is also okay, but mean cycle time, no. See, this is for development. It does not mean anything for her. She wants that it should not fail. If it fails, then it should be repaired easily. That's what she wants. So mean time to because this is incident management. Incident management does not include actual development and this and that. It includes when the bug comes, then it is an incident. How do you manage an incident? So mean time to failure, mean time to recovery, mean time between failures, change, deploy, cycle time won't come. Perfect. So incident management is a main keyword there. DevOps lifecycle. Your company has been working to increase the frequency of the deployments for new features by optimizing its full development and operating lifecycle, means DevOps. The CEO wants to cut the unnecessary phase to deliver new products. Okay. Which phases are not part of the core DevOps? Okay. अरे यार एक लाइन बोलनी थी सिर्फ ये बिल्कुल फालतू का था. Planning, coding, deploying, monitoring, this is not there. This is not there. Yeah. Okay, DevOps questions, DevOps practices questions are done. Now let us see Docker questions. The DevOps team has created the Docker file to help create their custom container images. Okay. Ubuntu they are using. Run get. Okay. Okay. They are installing Apache 2. They are exposing. Expose only says that it shows the intent that we want to use this port for TCP. We want to use this port for UDP. It's not actually assigning that port. Environment variable got created, Apache log dir. Okay. Add. So what they are doing is they are saying that this file has to be added to this folder. Okay, chalo. So when the following commands are run on the Docker file, what will be the result? Docker build tag web server 1 and Docker run detach. Detach means run it in the background. And name is this. So run means basically you create a container from this image and also run that container. Okay, okay. Apache 2 will be installed in the containers image. Yeah, true. It is happening. The containers port, this will accept TCP traffic. No. Containers port, this will accept UDP traffic. No. You are only telling your intent. Okay, so these two things won't happen. Environment variable will be set in the environment of the containers process. Yes, because this is environment variable of the container, not of the host machine. The environment variable will be set in the environment of the host. No. Apache 2 will start on Ubuntu. No, it won't start. It will only get installed. A remote file will be copied to the containers image. Correct. 100%. Kya baat hai. Docker ports. So what is to be done now? The team responsible for configuring the new Docker application wants to allow access to applications database server containing on a container on the containers port this and machines port that. Okay, machines port is this, no? So okay, and they also want to allow connecting the web server containing container via the machines port this and that. Okay, okay. So web server, these are the ports, and database server, these are the ports. Okay. Now complete the following Docker compose YAML so that it implements those requirements. Okay. So this is HTTPD and MySQL. MySQL is the database server, and web server, Apache's web server is called as HTTPD. D does not stand for database. D is Apache's web server. तो ठीक है, तो Apache's web server ना machines port is this and containers port is this. So okay, here it should be 8080 and here it should be 80. Then MySQL means your database server container. Okay, container port is this 3552 and machines port is 7452. Okay, perfect. Docker limits. The development team wants to ensure that the containerized application will not consume too many resources in a shared environment. The application must run on a host machine with severely limited data space. However, it can consume up to half of the host's 32 GB RAM, means it can consume up to 16 GB RAM. While the host machine has 8 cores, the application must be limited to using no more than half these cores, means out of 8 cores it should only be using 4 cores, 16 GB RAM, 4 cores. Okay, now which Docker run options can be used to meet these requirements? So you have Docker image. Now create a container from that image and run. So that is Docker run. So docker run command also has a few options that you can give, and these are a few options that you can give, and it will tell that how much CPU or RAM or disk space this container should be running. So disk space is highly limited, so ROM is limited, leave that. Okay, now see, I should be using 16 GB RAM. 16 GB RAM is given here. Yeah, so it's one of these two. Then I want 4 CPUs. 4 CPUs are given at both the places. Now memory swappiness is 0 and memory swap is 16 GB. So this is the correct option. Swappiness cannot be 100. Swappiness means since the disk space is very low, I don't want it to swap memory at all, because I have very little disk space. So memory swappiness should be 0, and then memory swap should be equal to whatever you have, whatever RAM you want to use. Okay, yeah, this is correct. For a test machine running 5 Docker containers, consider the following startup script. Docker network create, bridge, custom net. Okay, ठीक है. Docker container run, name is Apache, from Apache image. Okay, and here network should be the same network which Apache is network container. It's the same thing that we just this network should be the same as the Apache one is working on. It is not the custom network that we just created. If you didn't give this, then it would take the custom network by default. Okay, then what? Docker container run. See, whenever you see D, it means in the disconnected mode, means run it in the background. So ignore that D. It doesn't matter. Docker container run, name is equal to nginx. Okay, it created nginx container from this image. Container run, add host, testdome.com. This is the IP address, and that is your MongoDB image. Okay, then so basically add host does this thing that within this container, wherever etc host file is there, it will be adding means that is a host file, right? It is like your local DNS, you can say. So when I say shirasao.com, then it means this IP address. So that thing you are saying, that when I say testdome, then I mean this IP. Okay, so that entry will happen in etc host file. So I think this is correct only. The container run, again create a new container and run it from this image, and network container of host. So wherever host is running, the same network I'll be using. Okay, now starts an Apache. So what does this startup script accomplish? So starts an Apache container in the background. Yeah, true. Connects MySQL container to the Apache network namespace. Yeah, true. Then connects the PHP container to the Apache network. No, it never said that. Start the nginx container in the background. True. Edits the Mongo containers etc host file. Yeah, true. Connects the Mongo container to the host through custom net bridge. No. Wait a minute. I'm not sure about this thing. And add testdome network, adds a testdome network namespace. When did it say? Testdome.com. This is the only place where a testdome is coming. No, I don't think so. Is this correct? Yeah. I was confused with this one. Connects the MongoDB container to the host through custom net bridge. Custom net is this bridge that it is forming. So host, where is host? Host is here. So it is saying whatever is the host network, connect me to that. Host network never said that I want to use this network. That's why I think. But this is a complicated question. So I'll do one thing. I'll ask AI. Okay, let us see here. I'm also confused. The second last option says that connects to a Mongo container to host through custom net bridge. The option is incorrect because Docker container run command for the Mongo container is structured in the script. Okay, Docker container run d add host this. Okay, fine. So what it is doing, default network. So since the command does not include network flag, yes, Docker automatically attaches to the container of the default bridge network, usually named as bridge. Custom net bridge, while the first line of the script creates the network called as custom net, nothing in the Mongo command actually references it. To connect to the specific bridge, the command should have needed to include network is custom net. Correct. So by default, the default network is always bridge. Okay. If you want to connect it to a certain network, then you should be saying -- network and then custom or whatever name of the network, right? Add host flag. So this is the reason why the option about editing this is correct. Okay, it can, okay, fine. ठीक है, I think that is good enough. Let's move ahead. Once again, a revision. Connects the MongoDB container to the host through custom net bridge. So custom net bridge it has not given only, ना, that's why. ठीक है. हाँ, namespace का क्या है यार? Explain. Last option also we'll see. Okay, let it come. By then we will read this. ठीक है. Hey, come on, man. Leave it. I'll start a new chat. Yes. So add testdom network namespace. Adds a network namespace called testdom. Okay. Is incorrect because Docker handles add host flag. Okay, ठीक है. What the command actually does is this. Okay, I get that. Why not network namespace? Because definition of a namespace, Docker or Linux, network namespace is a complete isolated copy of the network stack, including routes, firewalls, and interfaces. Creating a new namespace is much more complex architectural event than simply editing a text file. DNS versus namespace. Add host flag is a DNS level override. It tells the container where to look for a specific name. It does not create a new network segment or a new isolated environment named testdom. Correct. The bridge connection. MongoDB container in the script actually being connected to the default bridge since there is no other network which is specified and not a new namespace. Okay, good. Okay, let's move on. As a part of the load balancing scheme, your company uses multiple virtual machines which can provision and deprovision Docker containers as demand changes. So it is infrastructure as a code. Complete the Docker commands with no additional arguments. that manage the life cycle of the Docker image. Okay, fine. I'll say Docker create name balanced container. Sorry, this is not infrastructure as code, because this is not infrastructure, to be honest. This is only containers as code. So this is Docker compose, you can say, or it's not even Docker compose because it's not even YAML file, so it's only Docker. Okay, pure containerization, nothing more. When a virtual machine completes startup, it runs this command to ready the custom container image. Docker create name balanced container from company image. ठीक है. When the load balancer detects high usage, it signals the virtual machine to make the container available to use. VM runs the command. See, it only created. So run command means you create as well as run. So here I think it is start. Then load balancer detects that the container has been underutilized for more than 15 minutes. It tells the VM to suspend the container to conserve the CPU resources. Okay, suspend. Suspend means pause. Finding the increased load again, the load balancer. Okay, awaken the container again means it's actually restart only, but what is it called? Resume or something of that sort it is. And after an hour of utilization, the load balancer gracefully. So I think this is stop. I'm not sure about these terms. This is not resume, it is unpause, I think. Start, stop, pause, unpause. Okay. So create, starts, pause, unpause, stop. Okay. Now the last question, container restart. So automated team is testing their background Docker web server containers. They need to cleanly remove the existing containers without leaving any artifacts behind. Then start the new containers. Okay, so first close the old containers, then start the new container, right? Complete the following Docker commands to achieve these objectives. Gracefully end all the processes in the containers. Host Docker compose stop. Okay, Docker compose. Okay, now remove the containers. So remove it is not RM, it is RM, not remove. Start the containers in the background. In the background means in the disconnected mode, D. Okay, good. So that's it. I believe I've already taken 1 hour. So thank you very much for listening. And until next time, Jai Parshuram. And please support our agitation against UGC regulations, which BJP government brought to destroy our country. So they want to break us apart on the caste lines. We should stay united, stay secular, and fight against communal forces like BJP and RSS. Until next time, Jai Parshuram. दोस्तों, आप में से कई सारे लोग मुझे कहते हैं कि आपके सभी वीडियोस आजकल अंग्रेज़ी में क्यों आ रहे हैं। मैं आपको इसका कारण बताता हूँ। देखिए, आप मेरी वीडियोस को अंग्रेज़ी से किसी भी भाषा में ट्रांसलेट कर सकते हो, यानी उसका अनुवाद कर सकते हो। तो कैसे करना है? आपको सेटिंग्स में जाना है, यहाँ पे ऑडियो ट्रैक्स में जाइए, और अगर आप हिंदी भाषी हैं तो आप ज़रूर हिंदी सेलेक्ट कर लीजिए। तो देखिए, यही अंग्रेज़ी में जो बोलने वाला वीडियो है, ये आपको हिंदी में बोलने लगेगा। इसके अलावा मेरा यह आग्रह रहेगा कि आप मेरे वेबसाइट shirasao.com को ज़रूर विज़िट दें। यहाँ पे आपको यूटिलिटी ऐप्स मिलेंगे जो रोज़मर्रा की ज़िंदगी में आपके काम आएंगे। कुछ लर्निंग ऐप्स मिलेंगे जिससे आप सीख सकते हो, अगर आप स्कूल में हो या कोडर हो या आप मैनेजमेंट पर्सन हो, यानी मेरे जैसे मैनेजर हो। सेल्फ इम्प्रूवमेंट के लिए कुछ गेम्स भी दिए गए हैं। क्विज़ेस तो काफ़ी अच्छी हैं। मेरा पर्सनल आग्रह रहेगा कि आप ज़रूर कोई क्विज़ देकर देखें। और अबाउट मी में मेरा रेज्यूमे, ऑफ कोर्स संक्षेप में यहाँ पे मैं अपने कंपनियों का नाम नहीं बता रहा हूँ, बट बाकी सारी जानकारी मेरे बारे में आप जान सकते हो। और ये तो फिर इसी यूट्यूब वीडियो का लिंक है, तो मैंने इस वेबसाइट के ऊपर भी दे दिया है। मुझे ज़रूर बताइए कमेंट सेक्शन में अगर आप इस वेबसाइट में कोई इम्प्रूवमेंट चाहते हो, और इसके आगे भी और ऐप्स इसमें जुड़ते चले जाएंगे। Until next time, this is Amit signing off. Jai Shri Ram.